Hey guys, it's Tanish, and in this specific video, I think this video is going to be like around 5 minutes or 10 minutes long. Okay, and in this video, I have actually talked about how I built this multi-modal graph that system specifically for the manufacturing businesses and how it actually helps them a lot to figure out the solutions or the questions of the real-time problems that they might face during their operational processes or production processes. Okay, so let me just take you through it. Okay, for that I have also like my whole backend and the custom Python like code that I actually written on this have been created all over here. I've also have spinned up my quadrant DB or vector DB vector database. Okay, to store the vector database. I'm gonna show to you live that how what kind of vectors has been uploaded into the special collection that we have over here, that test collection. I'm gonna show to you all. You just have to wait and watch it out. Okay, and also like I have a specific document open over here that our like program is actually first of all splitting into an hierarchical graph in terms of JSON format, and after that we are converting it all into specifically into the vectors that has been actually after that again being uploaded in a vector database in our collection. And also we are actually using the vision models because we also have our LM Studio local LMs being spinned up over here. That is an embedding model to convert the actual human understandable text into vectors. Okay, that our LLMs can actually for the similarity search and semantic searching. Okay, I'm gonna take you through that as well. Okay. First of all, why does the vector DB is actually being used? And so most of you might have already been knew that vector DB isn't something that actually stores the data. It's only being used to actually just for indexing. It's a really and highly intelligent database compared to your normal database like SQL, MongoDB, and all those things. It's a much more intelligent database because, for example, if I'm looking for something regarding car. Okay. So MongoDB, so like in SQL, I have to specifically mention the word car, okay, to get all the rows regarding related to car from a table. But in Quadrant, I just have to only mention if I will also going to mention a word that is related to the car, that can be a vehicle, okay, or a four-wheeler vehicle, something like that. Quadrant going to use its similarity search and it will going to figure out that in which that this word maps out near which word. Like, is it near the car? Okay, the car is actually near this four-wheeler or the vehicle word. These two are actually like pretty close to each other in the graph, in the multi-dimensional graph, basically. That's how it will be to figure out, okay, like there might be the user might be looking for car. It's a probability kind of a thing. Of course, I have not specifically mentioned the car. Okay, the probability is going to be like around 0.7, 0.8, but it will still going to figure out with what kind of data I'm looking for. So that's why vector database are much more intelligent databases compared if you're going to compare to SQL and all those things. Okay, but again, it requires a lot of processing. Okay, to convert those steps into vectors and then to upload it and to actually kind of do the similar research as well. Let me show it to you all now. First thing that have over here is the main Python file that is the graph builder.py. Now, this specific file is the only specific file that is converting the whole complete data. Okay, this is the only file that is converting the whole data that we have over here into a graphical form, in a graphical hierarchical form. Okay, in terms of JSON format. Okay, because of course we cannot just produce the vicious format of everything. It will be like too big. Okay, so first thing as you can see, I have created the API key. So you can also see this API key doesn't matter because it's an studio's API key. Okay, I have a video running over locally in my PC, so it doesn't matter. I have actually just implemented it right now here. In future, if I have to swap my local LLMs to the cloud providers like OpenAI or OpenRouter or something, I can just do that like by just changing the API over here and approve it or more things. So as you can see, okay, I'm actually just first of all initializing the main object variables in the class, okay, in the constructor function. Now, this particular function is really important. Encode image. Now, this image specifically is being used to convert the graphical representations in our particular DB, for example, like these images. Okay, this figures and images like these. Okay, you know, a very intelligent and smart RAG system also has the description of the figures and images. Okay, this is really important. because these figures is actually contains a very high amount. Let me just show it to you. Okay, these images contains in a very high amount. As you can see, there's a lot of like these images consistent, like between in the whole like lessons and chapters and sections. It's really important for our like vector database and our rack system also to be able to understand and able to find out if any of these figures or images related to any particular question or answer that I'm about to give. That's why I created this whole thing. It's really intelligent. It's really useful as well. It's not just something that I have created out of the blue. Okay. So first of all, what you're doing is that whenever our blockchain is going to figure out that I have found an image, it will going to first submit that image. I'm going to run this particular function. It's an abstract function because you can see the underscore in the front of it. It's an abstract function, means it's being called internally by other function. We are not calling it directly. Okay. First of all, I'm actually creating the image. Now I'm first after that I'm saving the image as a PNG file. Okay. And then what we're doing is that I have actually created a buffer. Okay, and I'm actually saving the particular image data into this buffer in the PNG format. Then I'm actually converting that particular image into base64 format that you see a list of strings, a very long list of strings that we actually converting the image into that form so that our machine can stand it pretty well. I hope you guys got that. Then what we do is analyzing the image. So now I've converted the image into the base64 format. I have to submit this image in the base64 format to the LLM. I cannot just directly submit a PNG image to an LLM. You guys see that in ChatGPT interface because that's like they make easy for general purpose and general people to use it. At the back end, they're also converting the image into base64 encoding format, and then they are processing it internally using the vision models or multi-model like models LLMs. So I have also doing the same thing. First of all, I have created a prompt, systematic prompt for my manufacturing process use cases, as you can see over here. That what kind of response I want to process in this image, what to figure out, and what kind of output to give. Then actually created the whole like message over here. Okay, first I put the system prompt okay, in general, and then my user image as well in the base64 image format, of course. And actually submitting the request and our VLM, like actually vision language models. So I'm actually using the Google's Gamma 4 E2 billion. So it has the vision capabilities and of course the tools using the tools as well. It doesn't have the reasoning capabilities, but it's fine. It's one of the best open source models, Gamma 4, one of the most intelligent ones as well. So it has the vision capabilities. So what it will going to do is that my particular image will going to be submitted to the Gamma 4, okay, and it will going to give me a response having the whole description of the particular image that I have submitted to it. Then we have the abstract ID. Okay, it's just something that I'm using internally again. We're not going to go through this because it's not needed. Okay, now here is the main function that is the build graph function. Okay, so what we're doing is that first of all, we're using this particular class from the document that is PDF Python options. I'm creating an instance of it. Customizations. We created an instance okay, of the regular converter so that we don't have to run all these format options again and again and again. I hope you got that. It's just an instance. It's just some customizations. It's the document converter itself, but with our manual customizations. Okay, should the programming you figure it out. It's object-oriented programming being used very simple. Then we have the file paths thing over here. Okay, and like we are iterating over every file in the list. Okay, that we have for like this we got. And now it's very important. For now, I'm only passing 40 or 20 pages. Okay, because this file is really big. Okay, it's 347 pages and it takes a lot of time for our, like whole system. I mean, like for our Python file to figure it out, all of it, and to actually, like even like putting all of the images in between to the VLM as well, descriptions, getting out descriptions and again and doing it like many number of times. It actually consumes a lot of time. Okay, so I'm actually do it for the 20 pages only at first for testing it out for demo purposes. Okay, we can do this for the 347 pages as well, but we have to be like, wait a long time. So PC, make sure that it doesn't get slower, my friend. Okay. Your like laptop or PC in which whatever you get locally. Then I'm converting the file using a convert function, putting the file path, convert all keyword arguments as well. We are in the conversion result over here, and I'm specifically like taking out the document for using the document property. Okay, I'm actually storing the document in this particular variable. Then I'm just like creating a root node over here. Okay, for each and every document that is being converted. Okay, there's a root node, root ID first of all, because now we are actually going towards the graphical hierarchical structure. Okay, so what we're doing is the first thing that is required is the root node. From the root node only, we have different branches and different nodes, and these nodes can have more different nodes and all those things. So this one specific node is going to be the first node for each and every file. Like for each and every file, there will only going to be the one root node. So this is that one root node. Current hierarchy, as you can see the zero, we have the root ID being sent over here for the hierarchy. It's simple. Iterating through the items in the current file. Now, this is really important. Okay, let's see. Going through it. First of all, we have the index. Again, inheritance, we're going to get the index and the element and level as well, because we're doing the doctor iterate items as well. And first one is showing the node ID over here, no problem at all. Okay, we have different VBox, bounding box page name as well, and all those things, which is going to be fine. Now, for each and every item that is being passed, we are actually creating a specific node for it. Okay, and bounding box represents that what is the coordination of the specific uh, item that is being passed. It's as simple as that. Nothing else. Nothing has been done with it. And then the page number. What is the page number on this in which the specific item consists? Okay. Then you have the file name. It's going to be really simple, of course, because we're already figured it out. Then I'm actually using this one thing only for the pictures. If in this instance, if the element type that this particular for loop is currently iterating through is an image. If it's an image and it's PDF as well, okay, what we're gonna do? First of all, I'm gonna convert the image into a base64 image, base64 string that I just told you guys about using the import image abstraction function. Okay, through the same like self object. I mean, then I'm gonna convert. Then I'm gonna assign the node type picture node content as analyze image function. Now, this particular function is actually making requests to our local LLMs, VLM, vision language models, and our Gamma 4 model, basically, local model, to actually figure out, this is really important now, to actually figure out what is the, like a description of this particular image using the base64 string that I actually possified over here. Look at the description, means the content, I'm going to post it over here. And if I'm going to find any exceptions, you just make the node of content as image processing error. It's as simple as that. I hope you got that. Then we have tables. Okay, if L for instance is a table item, kind of you can think of it like in the same way that we're going to convert the element to the markdown format to store it as a content because it will be easy to understand by the LLMs and our embedding models also to be able to convert it and to do similar searches on it in the markdown format. It's more even the markdown format okay, to do the similar searches. Then something for the text that I'm doing. Okay, custom changing it, the same for the heading and all those things. Then I have the build references also. This one is really most important parts now. Because let me just show you now. Okay. With the extracted assets over here, here we have the ultimate graph.json file. Let me just show it to you in the very top of it. You see, here we have the root node. The first node is the root node, as I told you guys. After that, we have the node 0, node 1. But how these nodes are connected, we have to also understand that because this node is a heading for one fundamental. But where is the but how will I going to know that all these nodes are that who are the children nodes of these nodes and who is the parent node of these nodes? For that, I've also created something that we call as edges. Okay, this particular edges connects the nodes to other nodes basically. It's as simple as that. This edges part is very important now. Let me just show to you. Okay, so here we have the edges. Let's start. First of all, as you can see, like it's the whole list of edges because look, now we have all the nodes randomly created. Maybe they're in the sequence, but still, like the hierarchical binary tree kind of relationship is still complex. So we know something. We should know a direction, an arrow that points out that which node is connected to whom and how many branches are open with the specific node. We have to know that. And how are we going to know that? We're going to use something that we call as edges. For example, source. Here, KSMA, while it's a root node, okay, has child. Who's the child? This guy is the child. I mean, this particular target. So with the node 0 as next, who is the child? Node 1 is the child. Okay. Same now, look, we are going uh, from node 0 to node 1. Okay, but we have to go reverse as well. Okay. to actually make this relationship a much more stronger, okay, for our advanced RAG system to go through all of it. Now, as you can see, the same thing that you're going to see is that first of all, as you can see, ASMEY node 0 has a maxed means of connected node, that is node 1, but we have node 0 is previously connected, means the parent node is node 1 as well. Okay, node 0 has a child of node 1, okay, and node 0 basically basically what we're doing is that we are going next on the node. Okay, let me just put it more simple for you guys if you're not able to understand this whole source relationship target part. Node 0 is connected to another node that is node 1. Okay, but node 1 is comes after node 0. So we need a backward relationship as well. So what I'm saying is that node 1 has is previous, like node 1's before node 1, we have a parent node that is node 0 that is connected to it. Okay, so the other thing is that now root is also being connected to the node 1 as well directly. As you can see, the root node was connected to the node 0 as a child. I mean, node 0 is connected to the root as a child, but node 1 is also connected to the root node as a child as well, because as again I said, single node can have multiple branches. And these branches nodes can have more multiple different branches in like child and parent node relationship, or like upward and backward relationship, like both we are doing here, like doing an action previous. Okay, but for the root node, we're using the child-based thing basically. For example, think of it in this way. Next is not basically means the child. Next basically means the next section, the next item that is coming in our PDF, in our document. Because as you can see now, node 1 has a child called is node 2. Think of it in this way. Node 1 can be a heading. Node 2 can be a paragraph in the section. It's a section. The heading is being taken as node 1. The paragraph of even the main explanatory part is a child of that heading, of course, if you guys know what I'm trying to say. That is what being like that is what being the relationship, that's how it has been created over here. So like all these edges represents a bulk amount of relationship, okay, of different nodes connected to each other basically. In the same way. In like a lot of these let me show you the picture type nodes as well. Picture. As you can see now. Here you can see it. In the page 37, we have one of a picture type element, but again, like we cannot store a whole base 64 string as of now. Okay, we can do that. I mean, like we can store the string as well into that directly into some kind of this particular JSON file only. And whenever our rack system, chat system is going to figure out that now it's not like this particular image is needed to be used, we can just grab that image out for the front end, convert it into the main PNG format again, the visual format, and you can just show it there as well. But for now, it was a specific image, but we like use our VLM to get a description, content of that image, not the image entirely, because that's what a really important part is. As an expert mechanical engineer analyzing this image extracted from a technical document, here is my detailed analysis. As you can see, we got the whole analysis in there, basically in the whole like markdown format as well over here. Okay, it's a long one. Okay, let's see how many images that we have over here. Okay, this, okay, as you can see, this is a little big one, good. This is a really, really big one. As I said, it's completely in the magnet form. It means the boldness. It means it's a level 3 of heading. Okay, if you guys know what I'm trying to say, that's how it is actually working. It's a node 200. So it comes really, really late. And the multiple relationship that is connected to these images are also being shown over here. So from the node 200, as you can see, node 199. I mean, node 199 is the previous node. After that, we have the node 200 as our item. Okay, and same with the backward relationship also to maintain. Okay, of course. And that's how it's working. As you can see, the node 170 has a child. 170 could be a paragraph, could be a heading. Okay, and have a child means 200 is an image. So basically, we are showing a diagram after a paragraph of about something. Okay, that's how we build a relationship from heading as a child as a paragraph, or the whole heading as a child as an image. I hope you got everything to say now. Okay, that's how it's working. And we have hundreds of packages because connections can be a lot of them. Okay, as you can say that if I will create a random nodes, how these nodes are connected. That's what these edges contains. I mean, a node can like all the nodes can connect to all other nodes as well. This is possible. That's why edges are way more. Edges are way more in quantity compared to the nodes I have. As you can see, the amount of edges. It's way more than the nodes because the relationship is really complex over here. Because node, the data points is the one thing, but how those data points are connected to each other and other different nodes is an entirely different thing. And that's what I've shown. And like as you can see, the half of the file is just consist of edges. Now we have the nodes over here. Okay, then I've created using this file. Let me just show it to you live right now. Graph builder.py. But okay, references or something means building the next, like next and previous and hashtag all these relationships that have been created. As we may basically done using the that only. I mean, if you got that or not. I mean, this is really important. The build graph is being done over here. References is specifically used for providing the relationship to the image. Okay, to the figure, to the image, to the tables, and to the over here. Metadata. That's what we're trying to do. That's it. Nothing else. Okay. As you can see, this is how this now draws cross file links and all. And that's what we're doing over here, guys. I hope you guys got to understood it completely. And I hope you first of all understood the ultimate graph JSON as well. Like this is one of the most important parts to understand for the graph system. Now the video is already very long. Okay, I'm gonna shut the video here only because it's going to get more and more longer. In another video, the part two of this video, I'm going to explain the whole other uh, required file as well. Because like after graph builder, you have the graph retriever. That is like one of the most important parts as well. Okay, graph writing engine that is actually converting okay all those graphs basically like this is the one who's actually responsible okay that is to convert that this particular graph ultimate graph of JSON into embeddings into the vectors in its own different form. Like for example, this is the form okay where we have all of our like data being created in like terms of different things. First of all, I cannot explain this way in this way because it's a very long thing. It's a very complex thing. So just wait for the other part two. I'm gonna explain this whole thing as well. Like, what is this now? Okay, we have two of these JSON files. Okay, this one is the first one. This is working as a root. As this one is the base of other JSON file. I'm gonna explain to you. Content ready test JSON means this JSON file is now kind of ready to get uploaded into the quadrant. I hope you got that what I'm trying to say. I'm gonna explain to you. Just wait for a while. Okay, I'm gonna show to you how it's always working. As you can see, text to embed. So we have a different file over here that is embedding subloader that's converting this whole text to embedded keyword pair into a vectors. And then those vectors are being submitted or being like uploaded to the vector database. I hope you got that. That's what we're actually doing over here. So thanks guys, that's what we're actually doing. I hope you got it. I hope you understand it completely. At least the part one that what is the importance of this JSON file and how complex it is. You can get the full picture in the part two. This is it for today right now. And I'm gonna meet you in the part two, maybe like 1 or 2 days after this video. I'm gonna upload it.